other people, but that's a well split. 566.
Okay, you need to open your packet.
That's nice.
Cool.
Hey, some people are curious from the last one.
Obviously. All right, guys, so we are now going to figure out limits with a different method. You're not always going to have the graph to look at. I may ask you to do them algebraically. So limits by substitution is really what we're looking at today. We have all these properties here. They're pretty intuitive, and I'm just going to show you how to use them rather than talking through every single one of those. So, no. All right, so let's look at number 1 here. I'm asking you to find the limit of 3 as x approaches 1. So with some of these, it's easy to think about the graph and then do it just like you did from 9.1. So what does y equals 3 look like? Because that's the graph we'd be thinking about. Yeah, 1, 2, 3, horizontal line, right? So if I'm asking you to find the limit as x approaches 1, what are you going to tell me? 3. Okay. So your takeaway from that is that if it's a constant, that's it. So if I asked you the limit of 7 as x approaches 17, it's just 7. Okay? All right, second one here. Again, we could think about the graph. We know what y equals x looks like, right? Just like a line like this. And then I'm asking you as x approaches -4. Well, what's your y value down there at -4? -4. Okay? When it's an algebraic expression like that, whatever your x value is approaching, try to just plug it in. So if I plug a -4 in wherever there's an x, I get -4, right? That's it. So with substitution, the idea is to substitute that value in, and that's your limit. The issues you run into is we can't divide by 0. You can't have 0 over 0. So those we have to do a little bit of algebraic manipulation, but other than that, it's just plug it in. So let's look at 3. So what do you think I'm going to do with that x approaching 1? Yeah, so 4 times 1 squared plus 3, what do I get? I heard 7 and I heard 19.
Oh, boy. Yeah, he's right.
Okay. Everyone go to the being 7. Yep, that wasn't a math as well.
Oh.
Just teasing. Good work.
Thank you.
All right, so yes, it is just 7, order of operations, exponents before we multiply. You just plug it in. Suspiciously easy. All right. So guys, try for me 4, 5, and 6 while I try to take attendance with how many of you are gone. Yeah. You don't have to grab it.
Wow, that's so good.
Oh, please don't read the 0. No. Please don't. I don't want you to.
Whoa, this is bringing back what's the cosine of 0.
Yes.
Oh,
Wait.
it's 1? Sorry. Wow, that was
scary.
It's times 0. Oh,
Wait, I gotta plug in.
It's I don't care.
I do.
So now we need to know what's the cosine of 0.
Are you guys done with all 3?
Yes.
It doesn't matter.
Okay.
It doesn't matter what it is.
All right, so we plug in a 1. 2 times 1 minus 1 over 1 cubed minus 2. So what's 2 times 1? All right, 2 minus 1 is 1. And what's the denominator?
-1.
So overall we get,
-1.
okay. Whew. What do we get for number 5?
2 plus 1.
No, just 2. Because it's only asking you, you're not solving with the square root. It's just asking you take the square root of this value. Number 6, what do you get? 0.
No, never really.
Cosine of 0 is 1, but it's times 0 squared, so yes. Good so far, right?
So far.
Wow, this is good.
Are we liking Unit 9 so far?
So far. Can we just stop now?
Yeah.
Or it's gonna get. Oh no, it doesn't look too bad.
No.
It's gonna get.
All right. Try 1, 2, and 3. Guys, when it says find the limits analytically, that just means like not necessarily. Really, it does just mean find the limit. If you need to draw a graph, you can, but just find it in a way that you know how. Yeah, guys, is E a variable or a constant? Okay, so what's it gonna be? Yay!
That was.
Sneaky. All right, guys, so what did you get for number 1? 9.5, yes. What about for number 2? And number 3? Okay? Easy, right?
Easy. I'm sorry I had to do that.
I like it. All right, guys, so let's do 12 together, and then I'll have you try 13. So I'm asking you to make a sketch of a graph such that the limit will not exist at these specific values. So for the first one, at 1, 2, and 3, the limit will not exist. There's a million different ways you can draw these, but I think a super simple one. You don't have to write the equation. You just have to draw the graph. So look at this. If I did a graph that looked like, I don't know, that. What do you mean just goes over it?
Oh, it's just, I got it. You're right. 1, it just goes.
No, because the limit would exist at 1, 2, and 3 then. So guys, you've got to have something that's disjoint here so that, like, from the left and from the right as you're approaching one don't run into each other. Does it have to look exactly like this? No. But you need, like, the discontinuity pieces in there so that the limit doesn't exist. You guys see it? Okay, so try 13 for me.
These graphs like very different first.
Yes, you can show your own personal style in your graphs, okay?
So it's always one.
I believe it. Sayonara. Really need your phone in the bathroom, do you?
No, but I just don't trust it.
Oh, that's understandable. Anybody want to come draw their graph? Oh, Christian. Hey. Christian is ready to show his style, guys.
High pressure.
This is going to be recorded for all.
Oh no. Alright, let's. Can I like rest my hand?
Yes, you can.
Let's see what that is. Oh, I like to draw. It's not working. I don't think it's on.
Oh, it is. It's delayed.
Oh,
You're
there we
okay
go.
now.
It's delayed.
Sometimes it does delay.
Christian with the puns.
I know, I like it.
Let's see. So it's gonna be this. Quality graphics.
Oh, that was good.
Okay. It's a circle.
Brilliant start.
Yes. Keeping you on the edge of your seat.
I know, the anticipation.
This is hard to like balance it all.
You have a new appreciation for it.
I do. Okay. Masterpiece. I should sign
That
it.
is, yeah, that's beautiful. All right, guys, again, doesn't have to look exactly like that, but it's got to be piecewise, like,
Yes. I'm very so much
okay, cool.
It's good.
Yeah, that's actually what I'm doing. I knew it.
It's
Okay, guys.
Spending bad jokes, you don't call them out.
All right, guys, so let's look at 14 through 19. These look sort of strange, but they're really not that hard. So we are given, as x approaches c, the limit of f of x is equal to 2, and as x approaches c, the limit of g of x equals negative 3. Then we have this lovely limit as x approaches c of the square root of 2 times f of x minus 4 times g of x. Intuitively, what do you think you should do there? So let's do that. So we've got the square root of 2 times 2 minus 4 times negative 3. So I get the square root of, which is, oh,
Wow, that was a good time.
good times. Rachel's so glad she came to this class today. All right, guys, try the next one. Good. Wow.
I did.
Wow.
Good time. It's pretty happy.
That's pretty happy.
So is that like x minus or x approaches c part like the relevant?
Well, it matters because it has to match C.
What if it
If
said
this was like A and this was B and this was C, then you got problems.
We don't get fun like that.
I mean, I could give you like, so I could give you like as x approaches A after like this, and I could give you another one as x approaches C after this. So you'd have to like pick which one, but that's all. Guys, go ahead and do through 19.
Okay, there you go.
I think you're fine.
We have another.
You want to buy it.
Can I do that? Forget it.
We could probably have some sort of fiesta at some point. It's just like another set of parentheses. Yep. All right, guys, what'd you get for 15? 27, okay. What'd you get for 16? 1, 17? What? 8, yes? No? Negative 12? Let's look. So f of x is 2 times 2 times negative 3. Yes, that is negative 12. What happened there for you? All right, what about 18? 0 and 19? 1, yes. Okay, any questions on those? Okay. We have some like calculus stuff to do with limits, but we're not going to do it today because of the shortened period. So we will stop there with 9-2.